Everyone, today we are going to discuss a problem CSIR mathematics examination in ODE subject. Problem: consider the ordinary differential equation for xy double dash plus 2y dash plus y equal to 0, that is initial condition y of 0 is equal to 1. Find the value of y double dash of 0. Given the differential equation for x y double dash plus 2y dash plus y equal to 0, that is divided by throughout by 4x, that implies y double dash plus 2 by 4x y dash plus 4x y equal to 0. Here p of x is equal to 1 by 2x and q of x is equal to 1 by 4x. Then x into p of x is equal to x into 1 by 2x, that is equal to 1 by 2, and x square q of x is equal to x square into 1 by 4x, that is equal to x by 4. Therefore, x is equal to 0 is regular singular point. Consider the given differential equation of solution is power series, that is equal to, let y is equal to sigma m from 0 to infinity cm into x raised to k plus m, where c naught not equal to 0. This is given equation number 2. Therefore, y dash is equal to sigma m from 0 to infinity cm into k plus m into x raised to km plus minus 1. This is equation number 3. Similarly, y double dash is equal to sigma m from 0 to infinity cm into k plus m into k plus m minus 1 into x raised to km plus 1 minus 2. Next, substituting these equation number 2, 3 and 4 in 1, then we get 4x into sigma m from 0 to infinity cm into km plus m into km minus 1 into x raised to km plus m minus 2 plus 2 into sigma m from 0 to infinity cm into km into x raised to km minus 1 plus sigma m from 0 to infinity cm into x raised to km equal to 0. Then 4x, that is sigma 0 to infinity 4 into cm km plus km into k plus m minus 1 into x raised to k plus m minus 1 plus sigma 0 to infinity 2 into cm k plus m into x raised to k plus m minus 1 plus sigma 0 to infinity cm x raised to k plus m equal to 0. The first 2 sigma is power of x raised to k plus m minus 1. So that's equal to common cm. Cm is common. Therefore, sigma m from 0 to infinity cm of k plus m into km minus 1 plus 2 of k plus m of x raised to k plus m minus 1 plus sigma 0 to infinity cm into x raised to k plus m equal to 0. Therefore, comparing this sigma m from 0 to infinity cm of 2 of m plus k into 2k plus 2m minus 1 into x raised to k plus m minus 1 plus sigma 0 to infinity cm x raised to km plus equal to 0. Therefore, comparing coefficient of x raised to k minus 1. Therefore, we get c naught into 2k into 2k minus 1 equal to 0. That implies k equal to 0 or k equal to minus 1 by 2, where C naught not equal to 0. Similarly, comparing coefficient of x raised to k plus m minus 1, then we get 2 into Cm into k plus m into 2k plus 2m minus 1 plus Cm minus 1 equal to 0. That implies Cm is equal to minus Cm minus 1 all divided by 2 of k plus m into 2k plus 2m minus 1, where m starting from 1, 2, 3, etc. m minus 1. Substituting m is equal to 1, then we get C1 is equal to minus C naught divided by 2 of k plus 1 into 2k plus 1. Similarly, C2, that's equal to minus C1 divided by 2 of k plus 2 into 2k plus 3, that's equal to C naught all divided by 2 into 2 k plus 1, k plus 2, 2k plus 1, 2k plus 3. Similarly, C3 and etc. so on. Cm is equal to minus 1 all raised to m minus 1 into C naught all divided by 2 raised to m into k plus 1 into k plus 2 into etc. into k plus m into 2k plus 1, 2k plus 3 etc. 2k plus 2m plus 1. From 2, we already know that the power series solution y is equal to sigma m from 0 to infinity Cm into x raised to k plus m. That implies x raised to k is commonly sigma out. That implies x raised to k of sigma m from 0 to infinity Cm into x raised to m. That's equal to x raised to k into C naught x naught plus C1x plus C2x square plus etc. Substituting the value of C1, C2 etc. Cm minus 1, so we get x raised to k of C naught minus C naught divided by 2k plus 1, 2k plus C naught minus C naught divided by 2 into k plus 1, 2k plus 1 x plus C naught x square all divided by 2 square into k plus 1, k plus 2, 2k plus 1, 2k plus 3 etc. C naught is equal to x cube all divided by 2 cube into k plus 1, k plus 2, k plus 3, 2k plus 1, 2k plus 3, 2k plus 5 etc. We already know that k are two different value, k equal to 0 and k is equal to 1 by 2. Put k is equal to 0 in this power series, we get y is equal to C naught into 1 minus 1 by 2 into 1 into 1 x plus x square divided by 2 square into 1 into 2, 1 into 3 minus x cube divided by 2 cube into 1 into 2 into 3, 1, 3, 5 plus etc. Then we get y is equal to C naught of 1 minus x by 2 factorial plus x square by 4 factorial minus x cube by 6 factorial plus etc. Given that y of 0 is equal to 1, that is x is equal to 0, then we get y is equal to 1. That implies 1 is equal to C naught of 1 minus 0 by 2 factorial, 0 by 4 factorial plus etc. That implies we get C naught is equal to 1. Therefore, y is equal to 1 minus x by 2 factorial plus x square by 4 factorial plus minus x cube by 6 factorial plus x raised to 4 by 8 factorial plus etc. Differentiating with respect to differentiating y with respect to x, we get y dash is equal to minus 1 by 2 factorial plus 2x divided by 4 factorial minus 3x square by 6 factorial plus 4x cube by 8 factorial plus etc. Similarly, differentiating y dash with respect to x, then we get y double dash of x is equal to 2 by 4 factorial minus 6x by 6 factorial plus 12 into x square by 8 factorial plus etc. Find out the y double dash of 0. Y double dash of 0 is equal to 2 by 4 factorial, for other value of the power series coefficient are 0. So 2 by 24, that's equal to 1 by 2. That is the correct answer, 1 by 12. Okay, thank you.